Detroit, Michigan. May 16, 1940. William Knudsen sat behind his mahogany desk at General Motors headquarters, the telegram trembling slightly in his hands. As president of the world's largest manufacturing corporation, he'd received countless urgent messages before. This one was different. President Roosevelt had just delivered an address to Congress that bordered on fantasy. The United States needed the industrial capacity to manufacture 50,000 military aircraft annually. Knudsen read the number again, certain there must be an error. 50,000 planes per year. This wasn't some middle manager making unrealistic promises. Knudsen commanded an empire of manufacturing. Over 200 facilities, 350,000 employees spread across the nation. His annual compensation exceeded $300,000, making him America's highest-paid corporate executive. He'd spent nearly 4 decades building his reputation in industrial production. He understood factories, production lines, and what was actually possible. The mathematics were staggering. In 1939, American factories had produced fewer than 3,000 military aircraft total. The entire U.S. Army Air Corps possessed approximately 1,700 planes, most of which were already obsolete. Roosevelt was now demanding production capacity equivalent to more aircraft than America had built since Orville and Wilbur Wright's historic flight at Kitty Hawk in 1903. Knudsen understood the deeper implications immediately. If the nation genuinely required this many aircraft, war wasn't just possible, it was inevitable. And when that war arrived, everything would transform. His comfortable world of automobile manufacturing, quarterly reports, and predictable production schedules would vanish. Within 14 days, Roosevelt would personally contact him with a request that would upend his entire life. Abandon General Motors and come to Washington to orchestrate America's industrial mobilization for war. Knudsen would accept without hesitation. The timing couldn't have been more dire. France was collapsing under German assault. Belgium had already fallen. The Netherlands was gone. Hitler's mechanized armies were racing toward Paris and the English Channel. Britain stood isolated against the Nazi war machine. Roosevelt was asking American industry to conjure an air force larger than anything humanity had ever witnessed. The fundamental problem? Almost nobody believed it could actually be accomplished. Especially not the Germans. Berlin, Germany. May 1940. Adolf Hitler received news of Roosevelt's speech with what his inner circle described as amused contempt. The Führer's intelligence services immediately prepared a comprehensive assessment of American industrial capabilities. Their conclusion was unambiguous. America could not produce 50,000 aircraft annually. The claim was transparent propaganda, designed to intimidate Germany while boosting Allied morale. The German analysis appeared logical and well-researched. American aircraft production in 1939 had totaled fewer than 3,000 planes. Even assuming maximum effort and ideal conditions, German intelligence estimated America might achieve 10,000 aircraft annually by 1942. The figure of 50,000 was pure fantasy. The German Air Ministry possessed detailed intelligence on American aircraft manufacturers, Boeing, Douglas, Lockheed, Consolidated. They understood these companies built aircraft individually, using traditional hand-fitting methods. Skilled craftsmen assembled each plane one at a time, measuring and adjusting components manually. Assembly lines worked for automobiles, not aircraft. The technical requirements were too complex, tolerances too precise, materials too specialized. A German intelligence report from June 1940 concluded that Roosevelt's speech represented a bluff intended to deter German aggression. The analysis stated that American industry lacked the necessary machine tools, skilled workers, engineering capacity, and raw materials to produce more than 15,000 aircraft annually under optimal conditions. The analysts felt certain of their assessment. America wasn't a military power. It was a nation of farmers and automobile manufacturers who had never mobilized for industrial warfare. The United States possessed no modern army, no strategic air force, no experience with large-scale weapons production. German planners calculated that America would require at least 4 years to construct the infrastructure necessary for serious military production. By that point, Germany would control all of Europe, rendering American intervention irrelevant. Hermann Göring, commander of the Luftwaffe, reinforced Hitler's confidence. Göring informed the Führer that while Americans manufactured excellent refrigerators and automobiles, complex military aircraft required German engineering precision. Americans lacked the industrial culture and technical sophistication for weapons manufacturing at scale. Hitler believed him completely. This belief would become one of the most catastrophic intelligence failures in military history. Meanwhile, in America, one man believed Roosevelt's seemingly impossible number might actually be achievable. Charles Sorensen was 60 years old in 1940, serving as vice president of production at Ford Motor Company. Born in Denmark, he'd immigrated to America as a child and devoted his entire adult life to Ford. In 1913, he'd helped Henry Ford create the moving assembly line at the Highland Park plant, a revolution in manufacturing. Before Ford, automobiles were built exactly like aircraft, one at a time, by teams of skilled craftsmen. Ford's assembly line transformed this process completely, breaking car production into sequential tasks performed by workers stationed along a moving conveyor. Each worker performed one specific job repeatedly as the chassis moved past their station. The result was mass production at unprecedented scale. By 1927, Ford had manufactured 15 million Model T automobiles using assembly line methods. Sorensen understood something the German analysts completely missed. The principles of mass production could apply to anything, including aircraft. The Germans were correct that American aircraft companies built planes like craftsmen, but they were catastrophically wrong to assume that method was the only possibility. Sorensen had witnessed the complete transformation of automobile manufacturing from craft production to industrial scale. He believed the same transformation was possible for aircraft. The question was whether anyone would give him the opportunity to prove it. January 1941. San Diego, California. Sorensen traveled to visit Consolidated Aircraft, the company that designed the B-24 Liberator bomber. Edsel Ford, Henry's son and company president, accompanied him. They toured the Consolidated factory together. Sorensen watched workers assembling B-24 bombers on the factory floor. No blueprints existed, just sketches and templates. Workers measured parts by hand, fitted them together manually, drilled custom holes, filed edges until components matched properly. Each bomber was slightly different because every part was custom fitted during assembly. The factory could produce perhaps one B-24 per day. Consolidated management considered this excellent production. They felt proud of their output. Sorensen thought it was insane. Sorensen saw what the Consolidated engineers couldn't see. The B-24 contained 1,200,000 individual parts. But those parts could be standardized. They could be manufactured on precision machines. They could be assembled in sequence on a moving line. The technology already existed. Ford used it every single day to build automobiles. A Ford V 8 engine contained over 200 precision machine parts that fit together with tolerances measured in thousandths of an inch. The B-24 was larger and more complex, certainly, but not fundamentally different. It represented an engineering challenge, not an impossibility. That night, Sorensen remained awake in his hotel room at the Coronado, thinking about what he'd witnessed. He knew how to mass-produce complicated machines. An automobile engine had thousands of parts requiring precise fitting. A B-24 had more parts, but the principle remained identical. Break the product into subassemblies. Standardize every component. Create tooling that produces identical parts. Build the subassemblies in parallel. Bring them together on a moving assembly line. Let the product move, not the workers. By 4 a.m., Sorensen had sketched the entire plan on hotel stationery and the backs of placemats. He presented it to Edsel Ford at breakfast. The plan called for a factory capable of producing one complete B-24 bomber every single hour. Consolidated's chief executive, Reuben Fleet, examined Sorensen's sketches and laughed outright. It couldn't be done, he declared. Aircraft weren't cars. The B-24 weighed 35 tons. Its wingspan measured 110 feet. Each engine alone weighed over 1,000 pounds. The idea of mass-producing bombers on an assembly line was absurd. Sorensen asked Fleet a straightforward question. If Ford agrees to build B-24s, will you provide the technical specifications and engineering support? Fleet agreed, assuming Ford would manufacture subassemblies for final assembly at Consolidated's plant. Sorensen said no. Ford would build complete aircraft or nothing at all. Either Ford could manage the entire production process using assembly line methods, or Ford wasn't interested. Fleet thought Sorensen was bluffing. He agreed to the terms, certain Ford would fail spectacularly. Sorensen returned to Michigan and convinced Henry Ford to construct a factory specifically designed to mass-produce bombers. The plant would be unlike anything that had ever existed. The factory would become known as Willow Run. Construction began April 18, 1941, at a site 35 miles west of Detroit near Ypsilanti, Michigan. The architect was Albert Kahn, who had designed Ford's other factories, including the massive River Rouge complex. Sorensen provided Kahn with the specifications. The building needed to be large enough to house an entire bomber assembly line under one roof. It required conveyor systems, machine tools, storage for thousands of parts, and space for tens of thousands of workers. Kahn designed an L-shaped structure covering 3.5 million square feet of floor space, the largest factory building in the world by a substantial margin. No structure this enormous had ever been enclosed under a single roof. The assembly line would extend 1 mile long, with a 90-degree turn halfway through. The plant would include its own power station, fire department, and hospital. Adjacent to the factory, Ford constructed Willow Run Airport with 6 runways so bombers could be test-flown immediately after leaving the assembly line. The airport featured 3 hangars, the largest capable of housing 20 B-24s simultaneously, plus a control tower, cafeteria, and hotel for test pilots. Total cost, $47 million. Equivalent to over $800 million today. The construction itself represented a massive undertaking. 300 men with saws, axes, and bulldozers cleared 100 acres of woodland. The site had been Camp Willow Run, a Ford-owned property used for youth camping programs. The land bordered Willow Run Creek, which gave the facility its name. A steam-powered sawmill from Henry Ford's Greenfield Village Museum converted felled trees into 400,000 board feet of lumber used in temporary construction structures. Building materials included 44,000 tons of structural steel. More than was used constructing the Empire State Building. Over 1 million square feet of glass provided natural lighting throughout the facility. The concrete foundation required enough material to pave a highway from Detroit to Chicago. The roof alone covered 78 acres. Workers installed 500 miles of electrical wiring and 93 miles of conveyor systems. The plant had its own water treatment facility and sewage system capable of serving a city of 50,000 people. Ford spent an additional $20 million on tooling and equipment, installing 7,500 machine tools, including massive presses capable of stamping entire wing sections. Some machines weighed over 100 tons and required special foundations. Everything about Willow Run was designed for one purpose: mass-producing heavy bombers at a rate nobody believed possible. German intelligence learned about Willow Run in mid-1941 through various sources, including trade publications and American newspapers, which openly reported the massive factory construction. Their assessment remained unchanged. The factory might be large, but America still lacked the skilled workers, precision tooling, and organizational capability to mass-produce aircraft. The German Air Ministry estimated Willow Run would produce perhaps 200 bombers annually at best, probably fewer. The factory was formally dedicated on October 22, 1941, in a ceremony attended by Major Jimmy Doolittle of the United States Army Air Forces, who would later lead the famous raid on Tokyo. Production began immediately. Parts manufacturing started that month. The first month, Willow Run produced 0 completed aircraft. November, 0. December, 0. January 1942, 0. By February 1942, 9 months after construction began, Willow Run had produced exactly 0 B-24 bombers. The plant was running, workers were present, machinery was operating, but no finished aircraft emerged. The problems were immense. American newspapers began calling the factory Willow Run instead of Willow Run. The name stuck and became a source of embarrassment for Ford. Congressional investigators visited and wrote critical reports questioning whether Ford's automotive expertise would translate to aircraft production. Senator Harry Truman, chairman of the Senate Special Committee to investigate the National Defense Program, toured the facility in April 1942 and questioned whether Ford could actually make the transition from automobiles to aircraft. Truman's committee was investigating waste and inefficiency in defense production. Willow Run appeared to be a prime example, a plant that had cost tens of millions of dollars but hadn't produced a single combat-ready bomber. The fundamental problem: Ford had never built aircraft before. The company had produced the Ford Trimitor transport plane in the 1920s, but that was small-scale production of a much simpler aircraft. The B-24 was orders of magnitude more complex. Workers didn't know how to work with aluminum. Automotive workers were accustomed to steel, which was harder and more forgiving of rough handling. Aluminum required different techniques, different tools, different training. Tolerances for aircraft parts were much tighter than automotive standards. Aircraft components had to fit precisely because any gap or misalignment affected aerodynamics and structural integrity. Cars could tolerate minor variations. Aircraft could not. The tooling designed for stamping car parts damaged the softer aluminum used in aircraft. Dies that worked perfectly for steel-crushed aluminum. Sorensen had to redesign and rebuild thousands of tools. The cost was enormous, millions of dollars in tooling scrapped and replaced. Design changes from the military came constantly, requiring retooling that stopped production. 575 engineering changes were ordered in the first year alone. Despite the setbacks, Sorensen kept pushing. He reorganized the workflow, retrained workers, redesigned tools, and broke the B-24 into 11 major assemblies and 69 subassemblies. Each subassembly was built separately on its own production line, then delivered in sequence to the final assembly line. The center wing assembly became the heart of the production system. All prefabricated structures were manufactured to precise specifications, so they would snap into place without custom fitting. A multifunction machine completed 42 precision machining operations to tolerances of 0.000 of an inch in just 17 minutes. The transformation from craft production to mass production required retraining the entire workforce. Ford established an aircraft apprentice school at Willow Run that trained up to 8,000 students per week. Classes ran continuously. Workers learned riveting, sheet metal work, electrical systems, hydraulics, and quality control. The training was intense because aircraft work demanded higher standards than automotive production. A poor weld on a car frame was unacceptable. A poor weld on an aircraft could cause catastrophic failure in flight. Workers internalized this responsibility. They knew pilots' lives depended on their work. In September 1942, the first completed B-24 rolled out of Willow Run. It had taken 11 months from factory opening to first aircraft. The plane was christened the Spirit of Ypsilanti in a ceremony that drew local dignitaries and press. That bomber wasn't sent to combat. Neither were the next 55. They were used for training and transport because the quality wasn't good enough for combat operations. Army Air Force inspectors found defects, incomplete work, and deviations from specifications. Critics declared the project a disaster. But Sorensen didn't stop. He used the rejected bombers as learning tools. Every defect was analyzed. Every problem became a training opportunity. Quality improved with each aircraft. In January 1943, Willow Run produced 31 bombers that met Army Air Force standards. February, 59. March, 75. April, 104. May, 130. The production numbers kept climbing month after month. Workers mastered their jobs. Processes improved through constant refinement. Tools got better as engineers identified and fixed problems. By June 1943, Willow Run was producing 190 bombers per month, more than double Consolidated's original San Diego factory output. And the rate kept increasing. The breakthrough came when Ford successfully integrated all 11 major assemblies into a synchronized production system. Wings were built on parallel lines. Fuselages moved through their own assembly process. Engines arrived from Pratt & Whitney and were prepared in a separate area. Gun turrets came from subcontractors and were tested before installation. Every component converged at the main assembly line in perfect sequence. In April 1944, Willow Run produced 453 B-24 bombers in 468 working hours. That was more than one bomber per hour, exactly as Sorensen had promised 3 years earlier when Reuben Fleet had laughed at his hotel room sketches. The factory operated 24 hours per day in 3 shifts. A new bomber was completed every 63 minutes on average. The final assembly line moved continuously at approximately 100 feet per hour. Workers installed engines, mounted wings, fitted gun turrets, connected hydraulic systems, and installed electronics as the aircraft moved past their stations. Each worker had a specific task and a specific time to complete it. The choreography was precise. At peak production, 42,000 people worked at Willow Run. The workforce was remarkably diverse for 1944 America. Most workers had never built anything more complex than a car. 65% were women, many of whom had never held industrial jobs before the war. African American workers comprised about 10% of the workforce despite facing discrimination in hiring and housing. The youngest workers were 18. The oldest were in their 60s. They came from farms, retail jobs, domestic service. Ford hired and trained them because the traditional pool of skilled industrial workers had been drafted into military service. Many workers traveled from Detroit on special buses because housing near the plant was limited. The trip took over an hour each way on roads that were often congested. Ford ran 165 private bus routes to bring workers to the plant. Public transit added 35 more routes. The federal government built an entire residential community adjacent to Willow Run to house workers and their families. The community was called Bomber City and housed 14,000 people at its peak. By the end of 1944, Willow Run had produced more aircraft than the entire nation of Japan built that year. Japan's total aircraft production in 1944 was approximately 28,000 planes of all types. Willow Run alone produced over 5,000 B-24s that year. And Willow Run wasn't the only factory transforming American aircraft production. Boeing in Seattle was building B-17 Flying Fortresses on assembly lines using methods similar to Willow Run. Douglas Aircraft in Long Beach was mass-producing C-47 transport planes. North American Aviation was building P-51 Mustang fighters, arguably the best fighter aircraft of World War II. Every major aircraft manufacturer in America had converted to assembly line production. The transformation happened in less than 3 years. In 1941, American aircraft factories employed 159,000 workers and produced 19,330 aircraft. In 1944, American factories produced 96,318 military aircraft, nearly double Roosevelt's original 50,000 per year target. In early 1943, the Germans began noticing something was wrong. Luftwaffe intelligence received reports about American bomber formations over Germany. The numbers seemed incorrect, too many aircraft. American bombers were appearing in formations of 300, 400, even 500 aircraft at once. German fighter pilots reported encountering endless waves of B-17 and B-24 bombers escorted by swarms of P-47 and P-51 fighters. When German fighters shot down American bombers, more appeared the next day and the day after. The Americans seemed to have an unlimited supply of aircraft. Albert Speer, Hitler's Minister of Armaments and War Production, reviewed German intelligence assessments of American industrial output. The numbers shocked him. American aircraft production in 1943 was over 3 times German production. Speer realized Germany had fundamentally misunderstood American industrial capacity. In his post-war memoir, Inside the Third Reich, Speer reflected on how German leadership had dismissed accurate intelligence about American manufacturing capability. Hitler refused to believe reports from German observers in America, insisting American production claims were propaganda. By 1944, American industry was producing twice the total war output of all Axis powers combined. German fighter pilot Adolf Galland, who commanded Luftwaffe fighter forces, witnessed the transformation of American air power firsthand. In 1942, his fighters dominated European skies. By mid-1943, the situation had reversed. American fighters appeared in overwhelming numbers. Even when German pilots had tactical advantages, they were outnumbered 5-1, sometimes 10-1. One German pilot described it as trying to hold back an avalanche. When American industry finally stopped wartime aircraft production in August 1945, the total count stood at 300,000 military aircraft built in just 4 years. From fewer than 3,000 planes per year in 1939 to over 96,000 in 1944, a 32-fold increase. The United States built more military aircraft during World War II than Britain, Germany, Japan, Italy, and the Soviet Union combined. The Germans had called it propaganda. America built the planes anyway. Albert Speer, in his prison memoir, wrote that the greatest German error was underestimating American industrial power. German leaders had looked at America's small peacetime military and concluded America was weak. They ignored America's massive industrial infrastructure, its engineering capability, its tradition of mass production innovation. Speer calculated that by 1944, a single American factory, like Willow Run, was producing more aircraft per month than entire German industrial regions. He concluded that Hitler's decision to declare war on America in December 1941 was the moment Germany lost World War II, not because of American military power at that moment, but because declaring war on America guaranteed that American industrial capacity would be turned fully toward destroying Germany. And once that industrial power was mobilized, Germany had no counter. The story of how America built 300,000 aircraft in 4 years isn't just military history. It's about Charles Sorensen staying up all night in a San Diego hotel room sketching an assembly line on placemats because he knew mass production could work. It's about 42,000 workers at Willow Run, most of them women with no prior manufacturing experience, building 1 bomber per hour through 3 shifts every day. It's about Roosevelt setting targets that seemed impossible and American industry meeting them. It's about German intelligence analysts fundamentally misunderstanding what was possible. The real lesson of World War II: industrial capacity matters more than tactics. Production wins wars. And American industry outproduced the entire world combined. The Germans called it impossible. America built them anyway.